light rays move from rarer to denser medium?
Speed decreases.
Speed decreases. Yes. What else?
Moves toward the normal.
Move towards the normal. Anything else left?
Sir, refracted ray greater than the incident ray.
Yes.
Oh, sorry. Yeah.
Incident ray will be greater than refracted ray. We just said reverse. Okay. Then,
Yes, sir.
no problem. When it moves from denser to rarer, what will happen?
Speed
Speed increases, yes.
moves away from the normal.
Moves away from the normal.
And the refracted ray is no.
Refracted ray is lesser than or greater than?
No, sir. I was mistaken. Okay.
Greater than.
Greater.
Okay. So refracted ray is greater than incident ray. So angle, I mean to say. So in this, when it is moving towards the normal, both angles are equal. Now we will just discuss one thing about apparent height. Then we'll move to our laws of refraction, refractive index, and absolute refractive index, so on. In this one, we don't have that much detail in this 10th standard, but we will have detail thing in when you study optics of your 12th standard, 12th grade or college, second year, whatever. In some place they call college, junior college, senior college. Okay. So when you drop a coin on this one, simple example is of coin. So when you drop a coin of this one, like it will go to the bottom. Okay. So one incident ray is normal on this object. This is your water. So a ray incident to this one, like passing through it on the coin, and we are observer. We are looking from here. So for this ray, if I draw a point here, ray diagram towards I, so its reflection will be here. So this is called apparent position. This is called actual. Now this height is called apparent height, and this height is called actual height. Now why this is happening? Why this is happening? What's the reason for this?
Difference in speed of light.
Yes. Difference in speed of light, or we can say changing medium. When light rays passing from changing medium, what will happen? It will like the speed will decrease. That means it is deviated from the original path. So actually it should go this. It is moving down. So instead of going from top, from the eye, let's go from bottom. So we saw that from the this coin will be visible at some apparent position. Apparent position somewhere. This is your actual position. Actually, it is here, but due to refraction and reflection, both. So yesterday only, sorry, not yesterday, before yesterday only we discussed, right? There will be always reflection and refraction together. So in this case, it will be visible. Okay. So it will show a apparent height, apparent position. So what will happen here? Just small small change in angle. Even we change angle of vision also. Instead of here, if we see from here, our vision is from here, still it will change. It will, instead of here, it will be somewhere up. Again, if we see from here, if we are looking from here, it will be a little bit down. Because this angle of incident and those angles are different now. So for your study, we don't have like apparent height and actual height formulas and all division and all that, so many things. Okay, you will have this one in on later studies, like higher studies, 11th, 12th. Okay, now one more thing, this is, okay, like this will be visible till at some point, at some angle. Until we see from here, just now I say like we can see from here, it will be some more angle here. Now, what if we are looking from here? We are looking from here. What will happen to this coin? This is okay, normal, we can see, okay, fine. What will happen to this point? Yeah, any idea? Anything you can tell me? If you're looking from this point or at this particular angle, more than 90 degree, then yeah, tell me, then what? Will it be visible or not? Yes, no, something. Are you able to understand what I'm saying?
Sir, the screen is fully black.
Will it be black? Okay. What are others? What other thing?
Sorry, sir.
Will it be visible or not?
Yes, sir.
Now see, nobody has idea, fine, no problem. If we're looking from here, it is more than like a normal angle, that is critical angle, the angle which is called as critical angle. If it is more than that, or it will be called as total internal reflection. Okay. If we are looking from here, it's just a 90 degree or some more angle, fine. It will be visible at this point, okay, on the top surface. But as this angle increase, as we are, sorry. So every surface, let's take water or glass or anything, or diamond. Now, why diamond are shining? What is the reason that diamond is shining or sparkling?
This is a refraction of light.
Reflection of light, yes, that is true. But what is the reason? Everywhere there is a reflection. Why it's not, this glass is not behaving as diamond, and why this is only behaving as a sparkling diamond? What's the reason behind that? If we make any glass in the shape of diamond, will it sparkle like that? Sparkle like diamond?
No, sir.
Why? What's the reason?
In a glass piece, the refraction takes place only one, and in diamond, it takes many times.
It takes many times, yes. Now again, one more question. Why is that? No idea?
Because it has many, many edges.
Many edges. Okay, one more question to you with that. Okay, don't mind. See, we have many edges in diamond. Fine, you said correct. Because of that, it's reflecting. Fine, it is also correct. So if I make a glass in the same piece, in the same shape of diamond, will it exactly same shape of diamond? Will it behave as a diamond, like sparkling or a shiny? Here comes like internal structure. See, because of internal structure or molecular structure of diamond is in that shape. That's why we are assuming, okay, we are making diamond as this shape. You see, diamond is just like some other one type of another stone or something like that. Okay, so we are making as a shape. So diamonds are like, their internal structure is like that. So it is internally behaving as a, like as we said, correct? It has a shape like that, and it has a property. How we got that property? By its internal structure. So when light enters inside the diamond, excuse me. So when light enters inside the diamond, it will take some time to exit. So when we see in a glass, light enters and exit. We know speed of light is 3 × 10⁸ meters per second. So it's moving in a fraction of a second from the glass. Even I'm wearing my glasses, it's moving. Exit at this speed, it's moving away. 2 × 10⁸. For glass, it is 2 × 10⁸. We'll see that later. Now, in this, okay, in this, what is a diamond? Yeah, diamond, it will take some time as compared to some other material to exit. So till then, what it will do? It will just keep reflecting inside, total internal reflection. So it will keep reflecting here and there, here and there, here and there, and it will exit. Same way, it so many light. It's not just we are just showing one ray. It is multiple ray. It is multiple ray moving here, another ray moving here, another ray moving there. So multiple rays. So because of that reason, diamond, because of total internal reflection. So with the same idea, we are using in some optical mediums, optical fibers. So in your home, you're using Wi-Fi, right? Home, your school, or wherever.
Yes.
So it's made up, it has optical fiber. Just let me show you one cut out of optical fiber, so you can understand that.
Yes, sir. When once I cut the wire, there was like glass kind of thing in there.
Glasses, exactly. Optical fiber. So in this, light rays travel, actually they are traveling in form of electrical signal. You know, like how light travels from our eye. If you have studied this chapter, like human eye, have you all studied human eye?
Yes, there in this chapter.
Not yet, sir.
Not started? Okay. So I, I guess you know already, like how, what is eye and what are the eye parts. Not exactly detailed, but actually you know, right? This is the eye and this is eye lens, and there are some optical fibers. Okay, what will happen? It will sense the signal. The rays are entering here. It will sense that image, and as an electric pulse, it will send to the brain. So brain will interpret it that this is what object it is. It is the shape, and that is there are some another tissues also, rods and cones, and we'll see that later. But in short, it is sent as an electrical signal. Same way, the light travels, light signals travels in form of electrical signal from the optics. Because you might have thought, okay, how this is moving, right? Because it's electricity. How we can see the light signal from there? So this is the fastest. We know that light is the fastest. So we are sending here, we are using this as an optical fiber. As a will send a light rays. Okay, it will carry some signals. So whatever it is data, whatever data it is, whatever data we are forming, like let's assume that Wi-Fi. In that Wi-Fi, it's forming, like we are sending a data, it's transferring. So it's that speed, 3 into the power 8. So we are saying that optical fiber or optical internet is the fastest internet, Airtel and all that. Everyone is giving some different whatever it is, range and all that, price range and speed and all that. It is separate department. So it is done by total internal reflection. So what will happen? This will keep reflecting here. These light rays keep reflecting internally. It will not leave until it is exited, until we give output for that. It will be like this. It will keep reflecting. One ray will keep reflecting. Same way, keep reflecting. Like that, how many rays we are sending? It will be reflecting, keep reflecting. So we are using this total internal reflection as optical fiber. Okay, let's come back to our topic, that is laws of refraction. What is first law?
Angle of incidence, angle of refraction, and normal lie on the same plane.
Incident. Yes, correct. Very good. Incident ray.
Normal and refracted ray.
Okay. That is law of reflection. So in this one, we can write here like this. It's same only. Let's write some different way. Incident ray normal ray, normal to the surface, and refracted ray. We are just changing this word, right? Reflected and refracted. Both laws are same. Laws of reflection and refraction. Same plane.
Sine of angle of incidence by sine of angle of refraction is equal to constant.
Yeah, it is a constant, that is refractive index. The ratio of sine of angle of incident to the sine of angle of refracted angle or refracted refraction is constant, denoted by n, or in some book it is mu. This is even called as Snell's law. So it says sine I by sine r equals to n.
So the constant is refractive index.
Yes. The constant is called refractive see, first law is easy, everyone can understand. But second law, what does it mean? What does second law mean? Can someone explain?
The ratio of angle of incidence, sine of angle of incidence and sine of angle of reflection.
Yes, that's correct. So how to understand this one? See, provided the medium is same. So we are using same medium, air and glass. So there is one angle of incidence here. So obviously there will be some angle of refraction. So the ratio, let's take number 1. Another angle, it's not same angle, it's different angle. Again, it's same, there is number 2. And some another angle. At 3. All these 1, 2, and 3 ratios will be equal because we are using same medium. So whatever angle we are entering and whatever angle it is exiting, that if we divide, that ratio will be same. So ratio between air and glass of the same glass and same air and same place. Angle if we change instead of this first 30 degrees and 60 degrees and 45 degrees, whatever degrees. So evenly they will have some exit angle. Their ratios will be equal. That's what it says. Sine of angle of the ratio of sine of angle of incident to the sine of angle of refraction is constant value. That is called refractive index. Clear, everyone? Both laws clear? Aditi,
Yes, sir.
clear? Both laws?
Yes.
Okay. Aaron, what about you?
Yes, sir.
Akshara? Shara, are you connected to audio? Amatullah? Understood both laws? What about Bhumika?
Yes, sir.
And Krishna?
Yes, sir.
Okay. Deepshika, Hania, Harini, what about you?
Yes, sir.
Yes.
Shreyan, Kavya?
Yes, sir.
Okay. Modita, what about you? Nihal, Ritvik, Itshika, Rohit, Saicharan,
Yes, sir,
Satvik,
understood.
Yes, sir.
Understood.
Yes, sir.
Done,
Satvik.
sir.
Okay. Sharanya, Udbhav, Ujjwal, all of you, right? Satvik?
Yes, sir.
Yes, sir.
Because,
Sir.
yeah. Okay. So because we should know like refractive index, because our total chapter is based on refractive index and formula. That's it.
Sir, then Snell's law and refractive index. Snell's law and second law is same.
Yeah, that is same.
Yes.
So it was actually a mathematician who gave this like a formula. If you want to know name, it's Wilbrod. Snell, S-N-E-L. Wilbrod, Snell. Okay, so whatever, it's now refractive index. Let's so there is a refractive index is the ratio when like speed of light is traveling or light is traveling from one medium to another medium. So what it says like it goes from air to some other medium like water or glass. So speed would decrease from air to glass or water. So in short, what is refractive index? Thus like a ratio or amount of change, what it is changing of speed. So that ratio of that speed will give you refractive index, absolute refractive index, or normal like refractive index of medium to another medium. So let's write some few points about refractive index.
Okay, sir.
This all points you already wrote there. All the same points. Let's combine those points and write. Speed of light decrease in denser medium. And it increase in error medium. So this the amount of speed of light in a medium. Now, what does it depends? The speed of change in medium depends upon
The lesser the speed of light, the greater is the refractive index.
yes. So how we can say that? Because of the medium, whatever medium we are using, like water or glass or air or whatever it is. So those all three mediums which I said just now, they have different properties. So this medium, this change, it depends upon that property of that medium. So depend on property of the medium. Now this property, what we said just now, that is called refractive index. So what is refractive index actually? It is the measure, it's a quantity or it's a calculative measure of like how much speed is entering from one medium to another. So we can say it is the like a measure or a calculation of this, just not for definition part, it's just for understanding part, whatever I'm writing here. Measure of how much speed of light changes when it enters one medium. From standard medium. Let's take standard medium as air. Shall I scroll down? Yeah, sure.
Yeah, sir, you can.
Okay. Next is absolute refractive index. Absolute refractive index means simple. Speed of light in air divided by speed of light in medium. But actually, standard medium can be air or vacuum. But generally, we would take air and vacuum both same. Yes, same values, 3 × 10⁸. but actually it's not 3 into 10 power 8, it's 2.99 for air, and vacuum it is 3 into 10 power 8. C by V. So N equals to C by V. Okay. Now, what will be unit? Unit of refractive index. Meter per second. Yeah, what it will be?
So nothing.
It's a ratio.
Ratio.
So
Yeah.
Yes. So ratios are dimensionless or unitless. Ratios are unitless. So right there, just 1 second. Oh, sorry, yeah. So what are unitless you wrote?
C by V.
Dimensionless. Okay. Relative refractive index. Now, what is relative refractive index? This was standard refractive index. Right, we saw like standard absolute refractive index from vacuum to some medium. Now, if we have two another medias, that will give you relative refractive index. Means what? Related to some other medium.
So same medium or different medium?
No, two different medias. Relative refractive index means from one medium it's passing to some other medium. This is standard medium, right? This is air is standard. We know all the values. But what if it's moving from air to some other medium and some other medium to some other medium? So they're asking, if they ask for some, like that day she gave one question, right? I think Saditi gave one question that day, like it's moving from X to Y, then Y to Z, then Z
Yes,
to...
sir. Air to water, then to glass,
Yeah.
again to air.
Yeah. So if there is a medium, so if we know only about air or some standard medium, we don't know about this intermediate media. So for that, we need relative refractive index. So what we'll do with that? First, we'll find out. Actually, this is not easy way. This long way. There's direct formula. We'll do that later. First, but understand this easy. This long way first. Normally, we have to find refractive index which is related to air. Then once we find the speed of that, then again use the speed to find some other. Then again use the speed to find compare with the first one. Then we can find in middle one. There is actually a long way, but we need to know that first. Then only we can find out some shortcut, direct formulas. Okay. So relative refractive index. It says like this. speed of light in medium 1 to speed of light in medium 2. So we'll write like this, 1 to 2. So speed 1 by speed 2.
So isn't it supposed to be V2 by V1?
No, we are finding here one speed of light in medium 1 to speed of light in medium 2. That is our formula. See, what is this? When light passes from medium 1 to another medium 2, the refractive index of medium 2 with respect to 1. So how will I write here? Refractive index. So let me write in word itself so it will be easier. When light passes from medium 1 to medium 2, the refractive index of medium 2 with respect to medium 1, we will write like this, N21. This is called as refractive index or relative refractive index. It is related to 2. Sorry, 1. 2 is related to 1. That's what they are saying. Now, if we multiply the above equation, this one, with the speed of light, 1, 2, speed of light, V1 by speed of light. So I can write this one as C by V2 into V1 by C. I'm just changing this one here. So what I'll get here? C by V2 divided by C by V1.
So it is used to find a relative refractive index.
Yeah.
Okay.
Actually, your formula is directly what I wrote above, that only formula, but I'm just making it simpler how to get different form. So C by V1 will be, let's assume as N1. So what is N1? Refractive index of medium 1. C by V2 is N2, refractive index of medium 2. Absolute, I mean to say absolute refractive index because it's standard medium. We took C as a standard medium. So 1, 2 can be written as N2 by N1. So what it says, the relative refractive index of medium 2 with respect to medium 1 is ratio of absolute refractive index of medium 2 to absolute refractive index of medium 1. So finally, we can write here as sine I by sine R. You know this? So sine I by sine R equals to what we got here, N2 by N1.
Sir, can you scroll a little up?
Just a second, let me finish this one. Just a minute. N1 sine I equals to N2 sine R. This one?
No, sir, the last point.
What's the last point?
Yes, sir.
Excuse me. Okay. So when reflection is happening, reflection of light is happening, like it's changing medium. Okay, fine. So what are the changes we can see? We saw velocity change, right? Velocity is changing. Then we see here wavelength changing, right? Change in wavelength. But what about frequency? Do frequency change?
No, sir.
Frequency is independent as it depends on the
Exactly.
source.
Exactly. Frequency does not change throughout. So during reflection, we can say wavelength speed or velocity is changing, but frequency is unchanged. Frequency remain unchanged. But by the way, what is frequency? What do you mean by frequency?
Some number of oscillations
Number
By
of
light wave.
oscillation. So,
by light
so,
wave per second.
so do light oscillate?
So I think it's a transfer.
Wavelength.
Okay, light is a particle or a
So it behaves as a transverse wave as well as a particle.
exactly. It is not just wave. It can be it behave as a both. It is a wave as well as particle. Okay, done writing?
Yes.
sir.
Few more things we'll write about this. Then we'll have a quiz. Do we have time? Yes, we have time. 8 minutes we have. Yeah. So what were we writing? N1 sin I by sin R. So we wrote N1 sin I, N2 sin R. So that means what? Refractive index of medium 2 with respect to medium 1 will be given as 2:1 V1 by V2. Same way, index of medium 1 with respect to medium 2 will be given as V2 by V1. So that is what you were saying, right? About this one? Somebody say it will be V2 by V1.
Yes, I.
Yeah. Okay, so if we multiply this to both, let's name it some equation 1, 2, 3, or let it be whatever. So if you multiply this one, sorry. into 1, 2. It will give you V1 by V2 into V2 by V1, which is equals to 1. So what does it mean? That day you gave formula, Aditi, right? This was you were talking about. One by N2. So it is reciprocal of this one. So
is it n1 square?
what N1 square?
On the LHS, sir.
No. It's not like that. We are just multiplying this one, this value. We are just substituting these values here. This value and this value. This is not actually n. It's not a variable n. It is refractive index of 2 to 1 and 1 with respect to 2. Those are refractive index of those. Okay. Okay. So what does it mean? Refractive index of medium 2 with respect to medium 1 is reciprocal of refractive index of medium 1 with respect to medium 2. So that day she gave a question. So what was the question here? N water to air, it is 4/3, I guess. And for glass and glass to air, it is 3/2. So when light goes from water to glass, so what we'll do? We need NGW, which is NGA divided by NWA, which is 3/2 by 4/3. 3, 3, 9, and 2 and 2, 4, 8. So divide and tell me what will be the answer? 9/8 is something 1 point something.
1.2. 1.12.
1, 2. Can we get exact value? Or it's just,
One second, sir.
is it multiple only?
Sir, 1.125.
1.125. Okay. Let's take this as an example. Water to glass we are finding. Water to glass. So water is down and glass is numerator. If they're asking glass to water, then reverse. Clear, everyone? So whatever we did, all this long thing, it is just for theory part, so that if in future, if you forget, then just if you read this one, you'll remember that why we are doing this. So no need to wait for anyone. You can read this one. It will be easier.
Yes, sir.
Is anyone writing?
No,
Sir,
sir.
can you choose the question, sir?
Yeah. Okay. You just finish it. I'm just posting a quiz link.
Oh, yes, sir, done.
Okay, some questions are from lenses. We didn't go through lens. Even power. Okay, join for quiz, everyone. Oh, let's go. Ready. For quiz, everyone ready? Yeah, this time. Good. Yo, we got this. Eleven members. 2 ran away. So still 6, 5 members more. All of 5. Which 5? Okay. Amatullah, join fast.
Yes. Modita, join fast.
Yes, sir.
Join for the quiz fast.
Yeah, sir, joining.
Okay. Yeah, I'll start the quiz. You join fast. Oh, let's go.